So we are recording and we're going to go to the camera. Okay, that's weird. Can you guys see the lesson? Yep. Okay, so lesson 28, identifying linear relationships from word descriptions. Okay, so today we are learning to identify a linear relationship from a situation that's being described in words. So there was not going to be a table or a graph today. It's going to be words. We're going to learn to identify the rate of change m and the initial value b from a linear equation. So given the equation, tell what they are and interpret their meaning by giving a word description to what it means. And we're going to connect word descriptions, equations, tables, and graphs as different ways to represent the same linear relationship. All right, so our first example. Get my highlighter ready to go here. To order a supersized sundae from Northwoods Ice Cream Parlor, it costs $5 plus 75 cents for each topping. If C represents the total cost in dollars of a sundae that has n toppings on it, then complete the following table. So in this table here, it wants to know what's the rate of change, M, including units. What's the initial value, B, including units? And what's the equation that relates the total cost, C, to the number of toppings, N? And I should have left more room here because I had a thought last night, but I didn't. When you get a question like this, it might be good to have a scrap piece of paper and think, table-wise, what would go in this column and what would go in this column, and then graph-wise, what would be on your vertical axis and what would be on your horizontal axis to help you. So we talked about if cost is involved, it's always on the vertical axis or the second column. And this would be your number of toppings. And this would be your number of toppings axis. So it says it costs $5 plus 75 cents for each topping. So if you got a no topping, you got a sundae with no toppings, it would still cost you $5. So $5 would be your initial value. Does that make sense to everybody? So if I'm filling in the initial value box here, it's $5. Because if I order a sundae that has no toppings on it, it's still going to cost me $5, which means my graph's going to start there. And then if I look in the question, it costs me 75 cents per topping. So that means as I get more and more toppings, I'm going to go upward. Okay. 75 cents a topping. So that's my rate of change, 75 cents. So make it look like money. So you're $0.75 cents per topping. And notice how it says you have to include the units. So there's our rate of change and our initial value. And if it helps you to either make a chart or a graph to kind of see what is happening in the situation, please do that on scrap paper. So our equation that relates the total cost C to the number of toppings N. So remember that we always follow for a linear equation this general formula, y equals mx plus b. But again, the diagram might help. Instead of the y-axis, we've got the c-axis. So we're going to replace y with c. Then our slope number is 0.75. That's m. Instead of x, we have n, the number of toppings, plus 5. So our equation would be the total cost is 0.75 times the number of toppings plus $5. And then it wants the meaning of the rate of change. So our rate of change is 75 cents per topping. Once you put units on, it's really easy to describe the meaning. So the meaning means it costs 75 cents for each topping. So if you just put 0.75 there with no units, it would be harder to figure out what the meaning was. But because it asks you to include units, it's easier to figure out what that means. But also it's in the question. To order a supersized sundae from Northwoods Ice Cream Parlor, it costs $5 plus 75 cents for each topping. So right here in the question, it tells you what the 75 cents means. So look for clues in the question. What does the initial value mean? That one's a bit harder, but we talked about it when we made our little chart and when we made our graph. It means that if you order a sundae with 0 toppings, it costs $5. A sundae with no toppings, you could write, or 0 toppings, either one, still costs $5. So before, when I've seen meaning of initial value, I've seen a lot of people write that the meaning is the initial value is $5. It wants to know more about this specific ice cream situation. What does the $5 represent there? So it represents a sundae that has no toppings on it. And then the last box here says determine the cost of a sundae with 5 toppings. So because we have the formula already, we can use the formula. And this 5 toppings we're given is N. That's what we're given. So we can find cost by replacing N with 5 using brackets because we want a 5 topping sundae. And then we can use our calculator and type that in. So 0.75 times 5 plus 5 gives us $8.75. So therefore, a 5 topping sundae costs $8.75. So we were given just information from a question. In the question, we weren't given the equation, just a situation. And the reason we know it's a linear situation is because it has an initial value and a rate of change. Okay? And as soon as you see a situation where you can see there's an initial value and a rate of change, you know that it's a linear, or it can be modeled by a linear equation. And from the situation, we picked out the rate of change, we picked out the initial value, we figured out what they meant, made our equation, and used it. Okay, so our next question, example 2. Martin's taxi service costs $5 to get picked up, plus an additional 80 cents per kilometer if C represents the total cost in dollars of a taxi ride and N represents the number of kilometers driven, then complete the following table. So rate of change M including units. And one big hint for finding the rate of change is the word per. So if you see something either increasing or decreasing by a certain amount per something, that's going to be your rate of change. In this case, the cost is increasing by 80 cents per kilometer. So there's your rate of change. Per is a huge clue for rate of change. So as soon as you see per, you're thinking M. And then we might as well go to this box right below because it's asking for the meaning of this rate of change. So our meaning is going to be that it costs 80 cents for each kilometer driven. So make sure when you write out your meaning, it relates right to the question. Okay, so this is about a taxi ride. So make sure in your meaning, it's understandable that you're relating it to what the question's asking or what the question's about or the situation. All right, so our initial value B. So Martin's taxi service costs $5 to get picked up. So just for them to come to your house and pick you up, it costs $5. And then if you change your mind and send them away, you still had to pay that $5 for them to come and pick you up, okay? So that's our initial value. So when I see this $5 to get picked up, anytime you only pay something one time, that's your initial value in a linear situation, okay? So how often do you pay the $5 to get picked up? Just once, so that's your initial value. The meaning of the initial value is it costs $5 for the taxi to pick you up. So before it takes you anywhere, it still costs you $5. So below, the next thing it asks for is the equation that relates the total cost C to the number of kilometers N. So below this line here, I'm going to put our y equals mx plus b. See if you could write the equation with C and N in it instead. So I'm going to give you a minute to think about it. Try it out. Even if you have to erase it, use pencil. But see if you can figure out what letters, which numbers go where. Does any grade 9 think they know the equation? Anyone? Okay. I'm gonna use a picture again then. So remember that if C is one of your variables, and it's your second column variable, which means it goes on your vertical axis, and N would be on your horizontal axis. So this is, instead of Y, you're going to change it to C, and instead of X, you're going to change it to N. So those two, if you can figure out which one's going to be vertical and which one's going to be horizontal, they should be easy to change. So I'm changing Y to C, and I'm changing X to n. The number that goes in front of n is your rate of change. So it should be 0.80, because m is the number that goes in front of x. Remember, m is always a number and b is always a number. And then your y and x are going to be letters or variables, okay? So your equation is always going to have two variables and two numbers. So our initial value is +5, so +5. So c equals 0.80n plus 5 should have been your equation. If that's what you got, great. And then our last question, determine the cost of a 15-kilometer taxi ride. So we're given, so here's our equation, c equals 0.80n plus 5. And we were just given n is 15 kilometers. And we have to find the cost. So we are finding cost, so we're going to leave c, but we're going to replace n using brackets with 15. And then we're going to get our calculator. 0.80 times 15 plus 5 is 17. So that's the cost. So therefore, it costs $17 for a 15-kilometer taxi ride. Okay, we've done two kind of similar questions. Go to the next page. Example 3. Cameron has $7,500 in her savings account. She spends $600 per month to rent a room for college. Okay, so she has $7,500 in her savings account. She spends $600 per month. So as soon as you guys see the per, you should be thinking this is probably the M, okay? She spends $600 per month to rent a room for college. If A represents the amount of money, and we know A is an amount of money, so it's probably going to be on our vertical axis. So this is going to be our A here. And N represents the number of months. So this would be, N would be my horizontal axis. Complete the following table. So she has $7,500 in her savings account. So that means her savings account starts like up high at $7,500. And if she's spending money, am I going to be going up from 7,500 or am I going to be going down from 7,500? So think about that. You're spending money, so the amount in your account is going to get smaller. So you're going to have a negative slope. So it's really good to, a graph can really help you sort out what's happening in the situation. So the rate of change, if you wrote it was $600 per month, you would only get like 1 out of 2 because really it's a negative rate of change. It's negative $600 per month. Because in this question, she's spending it. So that word spend means that the amount in the account is being decreased or it's decreasing. So then let's go right down to the box below, which is the meaning of the rate of change. So you could either say that she's spending $600 a month from her account, or you could say her account is decreasing by $600. The amount in her account is decreasing by $600 per month. Okay. So either one would be fine. Cameron is spending $600 per month, which is decreasing. I'm just making sure that I'm being understood. The amount in her bank account. So this decreasing, whenever you can write the word decreasing, that's explaining what the negative sign means. Or you could say reduces the amount in her account, or she spends $600 from her account each month. And then her initial value, so she starts with 7,500 in her account, so that's going to be our B. So she starts with $7,500. The meaning of the initial value then, right below, is Cameron starts with $7,500 in her savings account. Just using words right from the question, but showing that I know how those numbers relate to initial value. Is that Sawyer? Just gonna minimize that for a second. Oh no, I can't. Hopefully Sawyer can get in. Okay, equation that relates. So remember, we always want to follow y equals mx plus b. Y is what's on our vertical axis, which is A. Oh, I guess Sawyer can't get in. Okay, I'm gonna have to go off this and come back on. There we go. And now that's gone, I think. So see if I can use the camera again. Oh, good. Can everyone see the lesson again?
Yep.
Yep. Okay, thanks. All right, so our vertical axis again was A. Our slope was negative 600. Instead of X, we have the variable N. And then our initial value was 7,500. So there's our equation. A equals negative 600N plus 7,500. And then our last question, determine the amount remaining in the account after 8 months. So here's our formula that we just made. And 8 months is N. So we're given N equals 8 months. And we're asked to find the amount A. So we're going to replace n with 8. So get my calculator. So it's going to be negative 600 times 8 plus 7,500 gives me 2,700. And then I have to answer the question. So determine the amount A remaining in the account after 8 months. Therefore, $2,700 remains after 8 months. So Cameron started with 7,500, spent 600 per month for 8 months, and now she's at $2,700 in her savings account. So this one was important because it had a negative rate of change that we had to interpret, and also we had to put into our formula. And remember, the graphs, the little sketches can really help you organize what variable you start with and what is on the right side of the equation. It can help you know whether you're going to have a positive rate of change or a negative rate of change. And it can give you kind of a picture of the situation rather than just using the words. And that's what we're going to do with example 4, which was actually an EQAO question a couple years ago. So the equation below represents the relationship between the mass of a block of ice M, and they actually had this melting block of ice, which is a good picture clue, in grams, and the amount of time since the ice started to melt, T in minutes. And then it gives you the equation M equals 55 minus 5T, and then it says complete the following chart. Initial value including units, and then right below the meaning of the initial value, the rate of change including units, and the meaning of the rate of change in this situation. So this one gave people quite a bit of problems the year it was on for a number of reasons that we'll talk about. But the first thing I would do is do a little graph. Because they give me the equation, I know that capital M is going to be what's on my vertical axis, and T is going to be what's on my horizontal axis. So and then I'm going to read the question again. The equation below represents the relationship between the mass of a block of ice, M in grams, and the amount of time since the ice started to melt, T in minutes. So most of you should know commonsensically that if a ice cube has a certain mass, over time, it's going to melt and the ice cube's going to decrease in its mass. So it's going to have a negative rate of change. That should make common sense to you. So it's going to start at a certain mass and then it's going to decrease as time goes on because it's going to melt. So does any grade 9 think they know what the initial value would be? In other words, what would that number be there? Where does it start off? How much does it weigh in grams? Anyone? It's between these two numbers, right? 55 and -5. Which one do we think it is? 55 grams or -5 grams? What makes sense?
5.
5? Okay, so that is what a lot of people, I'm glad you said that. That's what a lot of people did. They put 5 grams. And they did it because they were used to seeing things in this format, y equals mx plus b, where the slope number comes first. But the rate of change number is the one that's attached to the letter. So in this case, It's the -5 that's in front of the letter T and the 55 that's on its own. They're writing it in a different way, okay? So we could rewrite it so that it had the mx part first, which would be the -5t. So the -5t part goes here, where the mx part goes, and then +55. And then we've rewritten it so it looks like y equals mx plus b. So one way to remember it is that the initial value is the number that's by itself. It doesn't have, it's not in front of a letter or beside a letter, okay, or beside a variable. So it's actually the initial value is 55 grams. So it's the number that is not right beside a letter. Number 5 is right beside a letter, T. And the meaning of the initial value in this situation is that the ice cube starts off with a mass of 55 grams. So that would be your meaning. It starts off, so up here, this would be 55 grams. And we know it's melting, so we know its mass is decreasing. So we know our rate of change should be negative because we know it's decreasing in mass. And we probably know it's decreased, the 5 goes with it, -5, but what are the units? So if you don't know the units, it goes in this y per x for units if you're ever stuck. So our y-axis is mass, which is measured in grams. And our x-axis is time, which is measured in minutes. So if I put my units as y per x, it's grams per minute. So my rate of change is -5 grams per minute. So a good way to do it is to figure out what's the units for the vertical axis and what are the units for the horizontal axis, and then vertical per horizontal, y per x would be how you write your units out. And then once you've got the units, it really helps you with the meaning. So the meaning of the rate of change means that the mass of the ice cube decreases by 5 grams each minute. I also had kids that year say that it was melting at a rate of 5 grams per minute. That's fine, that's perfect. The mass of the ice cube decreases by 5 grams each minute, or you could have write ice cube is melting at a rate of 5 grams per minute, or each minute is fine, okay? But the melting takes account for the negative sign, or the decreases by shows you that you know that the rate of change is negative and why it's negative. So remember, when you're doing these, they try to trick you by writing your mx plus b as b plus mx or b minus mx, okay? They switch up the right side, so don't let them trick you. Remember, the number that's in front of the variable is your rate of change, and the number that's on its own is your initial value. All right, I'm gonna exit out of here and then pair people up.